eventually the workshop, because it's a question that is asked of me so often. Yeah, it's all very well talking about this and that and the other thing, but how do I actually normalize and modernize some of the big files that I have in the database that are hit by so many application programs all over the place? So a long time of agitating over this, I've come up with a possible solution which is not going to put your applications or your database at risk. 3 prerequisites that are, and I'm sure you all have them, so an understanding of the normalization theory, familiarity with DB-triggered programs, and the understanding of the concept of I/O servers, because it all revolves around the use of those components in the proper manner. The object of this whole exercise is to do this whole thing, this modernization of legacy heritage systems, with absolute transparency to current production workload. I don't want it to impact the current workload at all. Modernize the process as you normalize and maintain the whole thing, i.e. the whole point of this is as you move forward to modernize it. No risk to the legacy application availability, that's another one again. There is a requirement for some downtime, we'll talk about that. Optimal third normal form database design as a result. Now you want to get there. It takes time to get there, and the whole plan needs to give you time to get there successfully, and then to test it, which is the important thing. Separation between your database model and your controller, which is your app code, and absolute data centricity. The whole idea behind this is to do a once, not a gradual, do a little bit here, do a little bit there, but take one file and do a complete normalization and data centricity setup with triggers, I/O servers, and all the rules and regulations that you need. So you move that one file into a completely modern environment. So there are probably a whole lot more that we want to achieve by this. But this is to give you an idea that there is a way of actually achieving this without breaking anything. And this is something I've been looking for a long time, because the breaking of things is not on the agenda under anybody's plan at all. And if you run the risk of doing that, you'd rather not do that at all. So let's have a look. Here, whoops, where am I? Right. Here is what you have at the moment. Now, when I had this in mind, I had one of 2 files in mind. I called it leg for legacy, number 1 file. It could be the ARP001, it could be the FLP001, it could be any file. And I recommend that you choose a file that's going to give you the most benefit. And that means probably one of the files with a lot of fields in the record, a lot of different types of data, something that will normalize easily and sensibly and give you benefit. And ALP is one of them. I mean, I've created 5 different files out of ALP already, and I haven't even looked at FLP yet. So you must choose a file. And the ones that you should target are the big central ones that give you the best benefit. Now, this is opposite from what most people think one should do. It's opposite in that people think you should take the little unimportant files in case something goes wrong. The idea behind this whole plan is that nothing's going to go wrong. So go for one that will give you the best benefit. Now, I know you have more than 3 legacy apps that are currently working on this, whatever this file is. So let's take it in steps and see what you have to do. The first thing you have to do is you create an after trigger which you attach to this number 1 file, whichever file you've chosen. You create an after trigger, and the after trigger maintains a file called the call log. All this trigger does is to recognize who called this file, what event it was, and the name of the procedure. And it puts it into the log file. So the log file is event and procedure name. And if it's already there, don't put it in again. You don't want doubles. You just want to collect in the call log all the legacy applications that are actually using this file. That's the purpose behind it. This will then become a list of the legacy files that you need to pay attention to when you come to need to make a few changes to them. So this is your log file. That's the first step. The next step is optional. We talked about this a little while ago. This is the change collector or change log file. You can optionally add that as well with a, and notice I've given this a separate trigger. I haven't put it in the same trigger. I've given it a separate trigger so that this one can be switched on and off, this one can be switched on and off, or they could both be on or both be off. And this will collect your before and after images and of records that are inserted, updated, and deleted on this file, and you can use that. We talked about this a few weeks ago, and this can be used for audit purposes. And you can also use it to check what is happening on this file. Now that basically is followed by one other process, and that is to take out the direct connection to your legacy file, or not take it out, but apply or build and make available an I/O server for your legacy file. Direct access to the legacy file is still available. You can have an FSpec in one of these apps. It can directly access that. But when you look at the call log and you see that program ABC uses this file to read or write or insert or update, you can go over time, one legacy app at a time, and you can change the app so that it uses the I/O server to access the data file and not the FSpec. This will gradually change the legacy apps to utilize the I/O server instead of direct FSpecs. And that, of course, simplifies your situation with this qualified files and qualified FSpecs, because it means in the program you're reducing the FSpecs and putting the FSpecs into the I/O servers and using the I/O server process as an access to the file. So it eliminates that problem as well. So this basically is a stage one where you can gradually, looking at the call log file, you can gradually pick out all the legacy apps that use this file. Now, interestingly enough, this will, once you've set this up for one file, you can set it up again for another file, and again for another file, and you can carry on doing this for multiple files. You're gaining some benefit. You begin to log what is using that file, and you've got a change collector which allows you to build audit reports if you want it on some files. And you gradually can change the legacy apps to use I/O servers instead of direct FSpecs. And there's no cost here. There's no potential risk, as long as, of course, you check to make sure that the I/O server is working properly. And if you come across an app that requires a certain I/O that's not available in the I/O server, you enhance the I/O server to provide that service for that particular app, and then you can move that app into the I/O server. So this blue block here can be done concurrently on a number of files without interfering with anything and without any risk. From Alan Cassidy, privately. Alan, can you just make those public? Can you have two after insert triggers? Yes, you can. You can have two of both of these triggers would be on the insert, update, and delete actions. And in total, you can have 300 triggers to one file. So you can have two programs attached to the after insert. They will be called one after the other in the sequence in which they were attached to the file. In this case, it doesn't matter which sequence you're using, but you can also, by using the right name within AO, you can control the sequence in which the triggers are called. So, yes, you can. And this stage can be evolved by different people, by different teams, without risk of causing issue. Right. Then we move on to the next one. What time do I have here? I just have to make sure. Okay. The next thing we have is we now start playing the fun game, which is the one I've spent, I think it's 4.5 hours so far, okay, on normalizing the file that I chose. So here is an exercise for normalizing this legacy #1 file. And I've got a bunch of normalized data. I apply my third normal form, and all neat and tidy and normalized as best I can. I then add the referential constraints between these normalized files. Remember, I'm doing this completely without any reference to what is happening on this other side of the screen. Remember, these are only indications. I could have 03 as a dependent of 01. I could have 01 as a dependent of ... I build my relationships to begin normalizing and controlling the data by referential integrity. Also making sure each one of these has a properly unique key, that there's a one-to-one or one-to-many relationship, and that it's all properly normalized. Once I think I've got it right, I can then go through and write triggers for each of these normalized files. Now, these are probably going to be before triggers. Some of them could be after triggers. They will contain the validations for that normalized file, and possibly after triggers will synchronize other files in the set. Be careful you don't wander outside the set at this stage, because we are working on a set of normalized files on a single large monstrous logical file. So once you've done all the triggers, you defined all the validation rules. Remember, where there's a relationship, there's no need to validate. And you want to put in the validations, you can go look and get the validation code out of the legacy app. Don't take it out of the legacy app, but at least you can go through the legacy app and see what sort of validations are required for the fields that you have left in that file. And so you can, over time, gradually develop the triggers to apply the proper validation rules to those files. The next step, now believe me, a lot of this is cut and paste, so it actually goes quite quickly. The next step is to create an I/O server for each one of these normalized data files. And pretty much cut and paste stuff using the newest version of the I/O servers that you've got with the inboard pointer and you create that. Now what you've done is you have created your normalization around that original legacy file. So you've normalized that legacy file without having busted anything, which is exactly what we're looking for. But now you ask yourself, have I got it right? Have I got the normalization correct? Do my validations do the right thing? Are my I/O servers working properly? I need to test my normalized database. How do I do that? And here is where we go to the next step. I would then, and remember this process can be happening in parallel with many other files. Some of your important, significant files this can be happening concurrently. Okay, let's see what we do. We create a copy, an empty copy of this legacy #1 file. We create an after trigger for this copy of the legacy 1 file. We create an I/O server, which is a very special style of I/O server, called by the after trigger, and it is past the after image of the record that was inserted, updated, or deleted from this #1X. And this I/O server takes that huge record, that monster N01 record, and it separates it and calls the I/O server for each of the normalized records, each of the normalized files. So this I/O server is almost like a separator. It's a parser. It takes it apart and updates, inserts, or deletes from these various normalized files, based, of course, on the rules that you have applied by triggers and constraints. So what you need to do when you get to this point is you need to add an error log file to this after trigger as well. The error log file is the method you can read in my pulling the trigger without shooting yourself in the foot article, where you can actually identify an error which could have come back from this trigger through that I/O server, back to this I/O server, and back to that after trigger. Instead of passing it on to the database, you pass it into the log file. And you keep it, you log it in the log file. Now what you're doing is you're testing to make sure that these triggers are applying the correct validations and that you're not trying to get away with invalid data. At this point in time, you still haven't touched the blue piece here. You've just evolved this process. By the way, this after trigger, the code for the error log file is sitting in there. You just have to add a call for this before you process the error if it comes back. Remember, we're percolating errors that we can percolate right back to there and up to the log file. Where do I get my test data from? That's easy. I get my test data. That green arrow should have been there all along. I apologize. I got the sequence wrong. I get my test data by using the copy file statement on leg N01F, and I copy records into leg N01X. Still no impact on leg N01F. I can copy one record, which of course will be inserted into this record. It will then be passed to the after trigger, which will call the I/O server, which will separate it out into its various different normalized components and insert these files after the triggers have had a look at it to see whether it's normal, and it will pass the error back to this trigger, and it will log the error if there was an error. Otherwise, it won't. So you can copy one record to begin with. You can then copy 100 records and see what happens. In this whole process, you can evolve the trigger rules, the IO server services, and you can modify this IO server here to, if there's any problems with putting data in the right normalized files. And all of this can occur, can be tested without touching anything that is happening here. This green arrow, by the way, should be there because legacy apps can either use an fspec and go direct to that file, or they can use the IO server and go through there. So all of this is now taking live data and pushing it through into the normalized database for testing purposes. Now, this can go on for months. What's this? Is copy file an NO1 trigger function? No. Copy file is the standard command copy file. Copy file, 10 records from that file to that file. You just copy from NO1F to NO1X. And this can be run on a command line. As you're testing this whole process, you can pick all the records for one customer, and you can run them across and see what they do in the normalized process. So you're testing your normalization, your relationships, your triggers, etc., and everything. If there are any errors in any of this, it all comes back into the error log file. You then examine the error log file, decide what the problem is, fix it appropriately, and maybe then delete this file, delete these files, and run the copy again and see whether the errors disappear. And so you can do this repeatedly with real live data. One of my biggest problems has always been, hang on, I'm getting there. You're ahead of me. So the biggest problem is test data usually doesn't, or is a subset. It doesn't work so well. Sometimes it gets corrupted and you miss things. This is a process of using absolutely live data. Absolutely live data to do this particular job. Now, at some point in time, you're going to have to stop and do a full copy. You're going to have to clean out these files, the normalized files. You're going to have to clean out NO1X, and then you're going to have to do a full copy from NO1F to NO1X of the entire file, which means you're going to be populating your normalized database with all the records out of your legacy files. And then what you do, what's going on? Why is my... Okay. That was in answer to your question. You can either do this, you can in fact do this at any time, whether these things are fully populated or not, but you might find relative constraint issues if you haven't fully populated this database. But if you make this after trigger here, an after trigger on this file, you get exactly the same result. You begin to populate or process data into this normalized database at the same time as you're processing it into this. So you now have two databases running in parallel. As long as, of course, you've populated this normalized section with a complete copy first, At that process, you have to stop the processing. I don't know if you've got the time. You can test it. Yeah. So you can test to see how long it takes by copying it in the background and populating this in the background. It won't be current because in the meantime, these apps will have updated stuff here that is not going through there. But you can juggle two until you are absolutely happy. You can input that in to see what happens when it's coming straight from that file, etc., etc. So you've got a number of options that you can deliver while you're in this process. Right. So I have now got 3 triggers, all after triggers, attached to leg N01F. If I want to, I can have them. The reason I've separated them into 3 different triggers is because this one was only added afterwards, this one is optional, and so on. So you can switch them on and off as you choose. Once you are happy that you've identified all the legacy apps, you can switch this one off. So you've got that sort of flexibility. And you are now in a position where you're actually running 2 parallel data. You're running 2 parallel files. You're running a normalized set of files for leg N01, and you're running leg N01. So the next step is where the crunch comes. If you have these 2 in sync, the normalized set and the legacy file in sync, you can move into the next process. I wonder why. Okay. Right. The next step is to get rid of the after trigger, get rid of the link to that legacy, and notice something here. I'm going to go back because I forgot to point it out. This one was named N01X and has been all the time. The first step is to rename it to N01F, which is the same as this name. I.e., although it's a completely different I/O server, it now carries the same name. As a result, any call to that I/O server, once you remove this one, any call from a legacy app to that I/O server will go to that I/O server. I.e., bypassing this completely and going through this process, which by now you have tested 1,000,000 times, and puts the record into its normalized database. You can, if you wish to continue using the error log functions, i.e. you don't want to crash your legacy apps yet, you can put the change log here and the error log files onto before and after the triggers on all of these files. You can just simply, it's pretty much the same trigger program. Don't build it into existing triggers that you've already tried and tested. Add it on as new triggers, 2 new triggers, one handling the error log and one handling the change log. And you have your complete operation now switched over, and all of that will disappear. So your legacy apps are now using this I/O server to distribute the big record information through the normalized database. Then the last step which you can choose to do either one app at a time or all of them at the same time is that, i.e. get rid of that I/O server and its calls to the I/O servers and replace them with direct calls to the I/O servers from the legacy apps. At the same time, you can look at taking out the validations from the legacy apps and converting those legacy apps to handle the triggers errors that are being returned. So, having done that, you will no longer have a legacy system. You will have pretty modernized applications because you will have had a tendency in the process to break them up and put them into procedures. So, whoops. Your call log file you should keep, because the call log file is in fact a list of all legacy programs that utilize these files. So that would be your checklist for legacy programs that need to be attended to. Thank you, Kent. I've agonized over this for many years. How do you handle file level and record level checks in the legacy apps that still use the file spec before they are changed to use the I/O server? You don't, because this file here is exactly the same. It hasn't changed. Its level ID hasn't changed. If it's using, let me go to slide 8. If it's using this I/O server to that file, the level ID hasn't changed. The minute that it starts to, it changes to this, sorry, obviously my processes. The minute you change to that, there's no file spec in the legacy app anymore. As a result, you do not have a level check problem, because there's no file spec in the legacy app for that file. Alan, are you happy with that answer?
I was referring myself to before you have all the legacy apps pointing to the I/O server. Because if you're pointing to the I/O server, I don't think the level checks come into play at all. I agree.
No, they don't.
But before you get all the legacy apps, you got them in the middle. Okay. So the legacy apps that have not been changed are still using that old file, and you don't take it out of the picture until you finish all the legacy apps. Is that right?
That's the point. You've got to time it properly and make sure you're comfortable before you move on to the next stage, which is from here. The next stage is getting rid of the green arrows and moving into this. And at that point, the level ID has no effect any longer. The level ID is handled in the I/O server, not in the app itself.
I got it. Thanks.
Okay. You're comfortable?
Yes, I am.
There is, however, one possible issue. And I know that it exists. I don't even have to know your systems backwards, but I know it does exist. in your systems like it exists in everybody's systems. You have batch processes for weekend, month end, and year end. So there could very well be a program, a legacy program, that is not in the call log file because you haven't run a full year. And so you are missing some legacy programs. And when you do a month end, I don't see you getting past this in a month, to be quite honest with you, although you guys seem to be quite speedy at this thing. But I think a month is too short. Of course, as you get more and more familiar with the normalization, things will get quicker and quicker, so you might. But you certainly probably won't have gone through a year end, and therefore there may be some legacy apps that are going to break because suddenly the file that they were looking for doesn't exist anymore. I haven't quite worked out a good way of fixing that. Maybe you can suggest something. But I haven't really got an idea. I don't know whether you have any. You could scan, I presume you could scan your source code looking for the file names. Some way, supplement the list in the call log file with those programs that are only run very infrequently. Whew. It sort of worked. I finished this, by the way, at 3:45 this afternoon. So. This gives you an idea of just how flexible trigger programs and I/O servers actually can be. This does contain some throwaway code. The after triggers up at the top are not thrown away because they're supporting this lot here in a slightly modified form. The only one that is really thrown away is that I/O server that is doing the distribution of information into the normalized database. But that would have taught you a lot and would have given you major support. Obviously, this last step, to now go and individually use the individual I/O servers, means there's probably going to be a lot of change in the legacy programs themselves, depending on what files have been normalized and what data is contained in each one of the normalized files. Because you might find that one of the legacy apps only updates this file, so it only uses that server, and so on and so forth. And that's how the evolution goes. Okay. I got to 5 o'clock. Okay. You've got Hawkeye or X-Analysis. Which one do you use, Kay?
We're currently on Hawkeye, but we just purchased X-Analysis, and we're still in the process of getting it up and running.
Okay. So that will probably be good for your cross-reference, and you can cross-check your call log against that just to see that you've got everything properly sorted out. Because one thing you don't want to do is to leave a legacy program unchanged and get it come up and bite you at year end, because you know what year end is like.
Every other day?
So this is the first workable plan for normalizing these huge legacy files that I've really felt happy with. I'd like you, if you can, to watch the recording. So it can compare to the call log, so you can actually use Hawkeye to compare the call log to make sure you've got everything, or identify at least the stuff this is missing, which is great. But then again, you're getting rid of Hawkeye. I hope X-Analysis can do the same thing. Right. If it's all right with you, and if you... What is your feelings of this, guys? I mean, do you feel that this is a good possibility? Thanks, Tony. Because this has always been a big problem with what we are doing is, yes, it's all well in practice, but in theory, but how do you actually put it into practice? And this methodology, this step-by-step process, is, to me, the one I'm most comfortable with in terms of putting the code together and making it safe to move in this direction. The worst thing that can happen is you bugger up the normalization and everything falls over when you try and do some test data. Then you've got to sit back and rethink it. But the second time you do it, it's going to be better. It's a learning curve, and it's going to take time, but at least it's going to be sure that you can move in the right direction without completely trashing or accidentally busting your entire system and having Michelle give you the look of unhappiness. Yeah, what Denise says there is the sort of thing. You can work in combination. One team can pick. Everybody, I would imagine, with Michelle in attendance, should pick the files you're going to tackle first. Pick one file you're going to tackle first. And then maybe the next time around you take two and see if you can do two at a time. The true risk or the difficult portion, and I know I'm going to see it when, sorry, I've now just, thank you. I didn't want you to tell me that. Let's just pick this slide just to get back at it again. You know, something happens with this WebEx. It makes it very slow sometimes. If you're handling the legacy number one file in one stream, so to speak, and you've decided to handle number two file in a second stream. So the blue section you do simultaneously. The orange section or the pink section, I don't know what color it shows up on your monitor, you do in parallel for file 1 and file 2. But then you discover, while you're normalizing file 2, that actually one of the file 1 normalized files, like this one, for example, here, which I'll tell you right now is an address file for your ARP, is also could be an address file for FLP, because they both require addresses. Now, when you get that situation where you get one file that's servicing two of your legacy programs, that's something I still have to think about. I need to have a look at it and try and find a way of overcoming that. But even if you keep them separate and then bring them together later. So you might have two address files, one ALP address file and one FLP address file. And later on in time, you bring them together. That's also viable. And it's not a crisis. Once you've got the stuff normalized, it's easy to begin consolidating files. Okay. So I'm happy to hear what you've got to say to me, because it really is great. And it gives you as much time as you need to get it right and to make sure nothing is going to break. And if at any point in time it becomes too much, or you guys are overloaded, the workload becomes too much of a hassle, you can stop. I would also lay down a start point at that time as well, so that you can stop and know when you're going to start again. But if things get out of hand, you can stop without anything causing a problem. So have a look through it. I will next week. Okay, Marinus has actually said to me, I must ask you please to think about it and to deliberately try and kick holes in this. I.e., try and find places where it's not going to work.
Can I ask a question, Tommy?
Yep, please do.
Okay. Now, please keep in mind I had to leave the meeting multiple times, so I did not get to hear the majority of what you said.
Okay.
What about files where we have joins over other files? Did you discuss that?
When you have files over?
Where we have a logical where we're joining two physicals, which we do with the FRP1, I know. How do we handle that?
Well, okay. So you're now talking about logical files.
Yes. Because once you start breaking down the physical, that would affect our joins. Granted, if if we were trying to convert the legacy. So.
Well, I would. Okay, thank you very much. You've just broken it.
You're welcome.
Case of specialist, everybody. She doesn't have to be here to break it. That's a compliment, by the way, Kay. It's not an insult.
I actually take it as a compliment.
We're talking about physical files here. Okay, so yes, where there are logical files, you might, instead of joining two physicals, you might need to join 4 physicals or 8 physicals even to produce the same sort of result. That one will have to review and see how it, I'm thinking now while I'm talking, and that's not always a good idea. Because with my mouth open and I'm thinking, I usually put my foot in it. It shouldn't be too much of a problem. Can you send me an example?
Yes.
Okay. Something perhaps over the FRP, ARP.
ARP. Okay, I'll see if I don't know if we have any on those, but I'll look.
Okay, but if you can. Because Pan says, could some of the logicals be handled by an SQL statement? Yes, they could. But that means changing your legacy code. Now, I'm all for trying not to change legacy code and not messing up level IDs. But the logicals are going to cause a problem. I know from the inspector that we did on your database that you do not have a very high logical to physical ratio. So it shouldn't be too complex an issue. And I'm sure we can find a problem for it. Not a problem for it. You see what I mean? We can probably find a solution to it. Well, the multi-record formats, Pat, we're going to have to review these, each as its own case. Using AO, you can get a complete list of all logicals. You can see which physicals they're attached to. And obviously, you're only interested in the ones that touch the first file you're dealing with. And when we get to that point, which I don't suspect is going to be before next week, Wednesday, although maybe, knowing you guys, you might dive in with both feet and get the hell on with it.
We are good.
Sorry?
We are good.
I know. You've caught me out a couple of times. Let's have a look at the basis of this whole thing and see how we can handle the logicals. I would imagine that they will be very much, they could even be serviced by IO servers, you see. I don't know. At this stage, I'm going to now go away, take myself an aspirin, and think about it, because you've just given me a headache.
You're welcome.
You're providing all this brainstorming that you've done with the other person is really good. I mean, you think of a whole process that gives a base, a base to work with. The others are exceptions that can be handled one by one, but to have a plan to start with.
Yeah,
that gives us as low risk as possible.
That is so important to me. I mean, I can't imagine what would happen if you try to do something like this and break your existing production system. It's just not acceptable under any circumstances. So it's got to be. And this is, for me, at last, I've got something that makes sense. Remember, at one point in time, you're going to have twice the data on your files. You're going to have the normalized version and the non-normalized version. Just remember that. You're going to need space. That's why maybe you do it with one file to start with, and don't try and do 26 files and have them all doubled up. So take it slowly, but I suggest this being a good starting point. And maybe you should even take ALP, or ALP, what is it? ALP 001.
Probably
Anyway,
ARP.
next week what I'll do is I'll show you how I've carved it up into about half a dozen files, the ALP. And you'll get the idea of A, how you do it, and B, how AO can make it easy to do it. Because in this process, this whole process on the right-hand side of the screen here, you also, Tony, want to start making sure you're using properly defined dictionary data names so that your normalized data fields are not your old prefixed versions. You mean the IO server can convert, this IO server converts that from one to the other. So that's the point at which you start pushing your dictionary to get it clean and neat and tidy and standardized. Okay, we overrun by quite a bit. I'm sorry about that. I know